Tonight, what I am going to be speaking about are biomarkers, and they are screening biomarkers. They're not diagnostic, and so that is something that can be used by the wellness community. And we're going to be talking about hormone analysis, metabolic, wellness profiles, and also what we call the mucosal barrier assessment. So what is the philosophy behind wellness testing? Well, we do know that if you look at the problem, we know that symptoms are a way in which we've always looked at dysfunction and how the body signals dysfunction. And the challenge has always been, how do you find the underlying root cause or even causes of that dysfunction? And you want to know that because the goal of all of this is to restore healing, balance, normal function. That's what we're doing every day. And so the pathway, in a sense, needs to be understood. You don't necessarily focus on the diagnosis or the treating of a disease. What you're trying to do in most cases in the area of wellness is to uncover what those malfunctions, what those dysfunctions are that require repair, especially when it comes to the whole issue of metabolism. And let me just say that we're going to be doing a quick overview, a very quick tour of what we do. And I'm fully prepared, Veronica, if you'd like, with your group to go into more detail in any future webinars, to go into any of these in much more detail. But let's look at the three areas, beginning with hormonal assessment. Well, the area that we're going to be talking about is actually on the right side. It's complementary or wellness testing. And that includes everything from cortisol to melatonin to secretory IgA. We'll be discussing all of these in a while, including the sex hormones. That really differentiates it from conventional testing that you would do for diagnostic purposes, which can be everything from FSH to TSH to free T3, looking at thyroid function and so on. That's not what we're looking at right now. So it's really complementary functional testing. And what we're looking at is this very, very well-known steroid pathway where you begin with cholesterol, and then you look at what I've shown here in green, which are some of the main hormones that we test for in a classic series of saliva hormone tests, which we're going to go through in a little bit of detail now. So why do you do the various testing? Why do you do adrenal stress testing, for example, if you want to look at cortisol and so on? And we know the reasons for that. It's everything from stress, either acute or chronic more often. What happens when people are in fatigue, they have low energy, they have abdominal weight gain, all of the classic sleep disturbances and insomnia, of course, anxiety and depression, and what is not discussed enough is if they have blood sugar imbalance, and how do the hormones figure into that? And the answer is very, very importantly, they do. So let's look at cortisol very quickly, and you need to remember that the cortisol curve, the diurnal curve, which you see in red, normally starts at the highest levels in the morning, 7, 8 o'clock in the morning for those who are not working night shift, and then it goes down over the day, reaching its lowest level in the evening. Melatonin, on the other hand, has its highest level in the middle of the night and then decreases, so it's at a low level by the time you wake up, stays at a very low level all day, and then goes into a higher level during the night. So one needs to remember the different profiles, both diurnal and circadian, for these. Melatonin in particular is an extremely important entity that we test for, more and more understood, comes from tryptophan and will normally form serotonin, and serotonin forms melatonin. Tryptophan can also form melatonin directly, and the bottom line is that we know that melatonin has always been associated with circadian rhythm. It regulates our sleep, but it does a lot more than that. It's also involved in chelation of many transitional metals, And in one way, perhaps most important, is its function as an antioxidant. It is one of the most important and most potent antioxidants available in the body. And it is involved in everything from regulating GI motility, local anti-inflammatory effects. It's involved in many other things, but most important, I would say, is mitochondrial protection. It actually, in the cell, protects the mitochondria by scavenging all of the free radicals which are created during normal respiratory function within the mitochondria, and it upregulates or increases the level of glutathione in its various manifestations. Extremely important. And so at the end of all of that, if you really want to know where melatonin is, it's extremely important in creating a good circadian rhythm, a rhythm of a 24-hour rhythm. And a good circadian rhythm, we all know, will create a decrease in oxidative stress. Whereas if you disrupt sleep, chronodisruption as it's known, you are going to increase reactive oxygen species, reactive nitrogen species, clearly not what you want. In the case of cortisol, we do know that cortisol has a diurnal rhythm, highest in the morning, goes down during the day, and in our tests, you can order various tests that look at the 4 cortisols, the diurnal rhythm, which is one of the most important ways of being able to see how the body is functioning, especially with chronic stress. It's critical. And if you lose the diurnal or circadian rhythm, you are going to see various diurnal rhythms which are not what you would normally expect in the various patterns where you look at hypercortisol curve in pattern 1 where everything stays high, pattern 2 where it starts to go down, and instead of staying down, it comes up at the end of the day, which is going to disrupt sleep and can cause levels of anxiety and depression. And then you have a hypocortisol curve in which someone is flatlining, as we say. They are down even in the morning, never come up, very low cortisol, and that is telling you that the HPA axis, the axis where the brain controls what the adrenals are doing, is just unable to continue to respond during sleep with an increase in cortisol. That creates what's known traditionally as adrenal fatigue. You also see it in Addison's disease, where the adrenals are just not able to produce cortisol. And without going into great detail, when you have chronic stress and you want to look at adrenal hormones, it's important to be able to look at the tests because it tells you what stages you are in. Are you in normal function? Are you in stage 1 where the body is being stressed but is able to still produce cortisol even at hyper cortisol levels, and eventually begins to go down through stage 3 and stay up to stage 2 and 3 until it fails. The adrenals say, that's it, I've had it, can't produce anymore. You really don't want it to come to that point. And so one of the tests that we do is called adrenal check. And what we're doing with adrenal check is we're actually looking at the 4 cortisols, the diurnal rhythm, the classic diurnal rhythm, and DHEA in its sulfated form, in which we really want to look at how well the adrenals are working. It's an indicator of the HPA axis function and what kind of adrenal output is there. So if you have chronic stress, we know that the mother hormone pregnenolone in the adrenals is going to, with chronic stress, begin to overproduce cortisol. At the same time, because it's overproducing cortisol, it starts to underproduce DHEA as well as some of the sex hormones as well. And so you end up with a classic elevated C to DH ratio. That means the cortical sum to DHEA. That ratio becomes extremely important. Its normal range, as you see on the upper right, is about 5 or 6 to 1, but that can change dramatically. And when you get used to doing these tests, you begin to see the ratio as a very important way of being able to identify HP axis dysfunction. It'll refine the therapeutics, because if the ratio is high, it shows you that there is adrenal dysfunction. DHEA and DHEAS, I'm not going to spend a lot of time on that, except to tell you that it is an extremely important hormone produced by the adrenals. It decreases with age. As you go through the decades, you see an overall decrease, quite substantial. And this decreased capacity will result in a decreased capacity of the sex hormones to protect the brain. And for those of you who do know that, you know that the sex hormones are extremely important for a whole number of issues, including protection of brain function, not just neuronal, but the various other cells in the brain. So when would you order an adrenal check? Well, clearly, if you're assessing endogenous hormone levels in general, you want to be able to measure hormone absorption, especially for females who are taking topical hormones in menopausal function, and especially those who are getting inadvertent exposure to the various types of OTC creams, the contaminants in the creams. You'll get a lot of information out of the adrenal check. But what most of the clinicians are ordering is some form of our female or male wellness tests. What that does is it gives you the adrenal check, but adds to it either the sex hormones, estradiol, progesterone, testosterone, or the one that is very popular and becoming more and more popular is what we call the stress and hormone panel, number 3 here, which is all of the things I mentioned, but with the addition of melatonin and secretory IgA, SIG-A. And I'm going to just very quickly mention what they are. The 3 sex hormones we are very familiar with. Remember that in the case of progesterone and the estrogens, you need to remember the typical monthly cycle in which estrogens, estradiol specifically, increase dramatically during the follicular phase, the early phase, which is the ripening of the follicle. Then you have ovulation in the center of the cycle. And then, of course, the ripening of the corpus luteum, allowing the cell to develop. That's the luteal phase. And that's when progesterone begins to build because, of course, you're getting ready in case there needs to be a cell that's going to not only ovulate, but is going to be stimulated into forming a, I'm just going to go back to this, sorry. So what is the result of chronic stress and cortisol in particular? It's extremely important to remember that cortisol has functions throughout the body, but specifically in the gut. And in the gut, it is extremely important in being one of the factors controlling GERD, which is gastroesophageal reflux disease, peptic ulcers. One of the things you see in IBD and IBS and a lot of food allergies is increased cortisol and therefore chronic stress, which is going to involve those functions. The slowing of the normal small intestinal transit time, meaning that the bacteria have a lot more time to build up an overgrowth of bacteria because they are not being pushed out of the gut in a proper motility. So it's extremely important for that. And last but not least is that it is involved with increasing intestinal permeability, which we used to traditionally call leaky gut syndrome. We don't do that anymore, but that's really what it amounts to. And one of the newest things that we've added to the test, and which is now called the stress and hormone profile, is secretory IgA, an extremely important measure of immune modulation. Low SIG-A or secretory IgA, that particular immunoglobulin in the mucus layer of the intestine, will tell you what is going on with the body's first defense in an immune response. If you have low Sig-A, a whole number of things kick in. It shows you that there's mucus layer dysfunction, which, as you know, is one of the first things that goes wrong when you're starting to develop dysfunction in the intestinal environment. If you have stress, adrenal dysfunction, it doesn't matter whether it's emotional or physical, you're going to get increased cortisol, which decreases Sig-A. That's important to remember. Various chronic infections, whether they are bacterial or whether they involve various types of fungal diseases, doesn't matter. That is going to create low Sig-A with all of these sequelae to that. Various poor dietary choices, which may be calorically rich, but are very devoid of nutrients, that can lead to low Sig-A. Various medications, especially anti-inflammatories, and I put a question mark on that, chronic food sensitivities, because the whole issue of food sensitivities is a very loaded issue, so we can discuss that later if you'd like. But Sig-A and cortisol do have a very specific push-pull effect. It is important to remember that with chronic stress, increased cortisol, as I said before, causes a decrease in the gut mucosa, both the lining and the amount that's being produced. And that's going to lead to a very negative influence on the levels of Sig-A. It brings it down, and therefore you're going to get a decrease at the same time of both the T and the B cells that are sitting in the Peyer's patches, which is the immune system lying in intimate contact with the intestinal layer of cells, and that's going to cause a decreased level of intestinal Sig-A and lymphocytes. All of that leads to a whole number of things, including, last but not least, yeast overgrowth. And so really what you need to remember is that with chronic stress, cortisol is interfering with the ability of the T cells within our immune system, which lie in the gut lining, for them to proliferate and therefore to regulate the immune response. So all of that is going to lead to lower levels of Sig-A due to high cortisol. And Sig-A in Candida, I'm not going to spend a lot of time on that, except that there have been two very recent articles that are really, I think, important in telling you that IgA, which is the immunoglobulin that leads to the creation of Sig-A, it targets the hyphal form of Candida. And without going into great detail, Candida exists in many forms, but the form which you don't want it in, that is very aggressive and can penetrate into other parts of the body, is the hyphal form, and it will exacerbate intestinal damage. So IgA, it turns out, is targeting the hyphal form of Candida, which is what you would want. So that means our immune system is able to distinguish between both benign and harmful forms of Candida. So the conclusion by these authors is that the adaptive immunity of the body is able to do a whole number of things. It's actually able to select and to target the hyphal Candida forms in the gut. And in that way, it suppresses the harmful effects of those particular fungal forms, and it is able, by doing that, to improve the commensal fitness, because by decreasing hyphal forms, it allows the spherical commensal form of Candida to proliferate, etc. So the commensal fungi, in those cases, IgA is uniquely capable of uncoupling the colonization from the pathogenesis of the various fungi, and in that way it is able to promote homeostatic gut function. I'm not going to spend a lot of time. I'm actually going to pass right through this and go to metabolic wellness profile. This is a second series of tests that we do. The first one, the hormonal, was saliva, which is the classic way to do it. We also now have a metabolic wellness profile, and this we do with dried urine. Literally, your patient or client sends us a little card that has dried urine on it, and we are able to use that to develop our reports for you. And what are we testing for? This first page on the left shows you our colorful report, and then we have a bunch of pages in which it describes commentary on what these are. And what are we testing for? Well, we test for three things. We test for digestion, for liver detox, and for cell oxidative stress. So let me very quickly tell you about digestion. Well, what we're testing for is protein degradation. Normally, you know that with normal protein metabolism, you've got classic proteolysis. So proteins are broken down into polypeptides and then into amino acids. Everybody knows that. That's great. What happens when it doesn't function as it should, when it's abnormal? Well, you're going to have a number of things that happen, including putrefaction. Now, what does that mean? It means that certain amino acids, like tryptophan, for example, are going to be used by bacterial cells. It breaks down the tryptophan because that's what it does for a living. And one of the substances that is a waste product of that metabolism of the bacteria is indole. Now that's happening all the time, but when it happens in large amounts, then it becomes an issue. And so in order to understand that, you need to remember that in the intestine, there's always a certain amount of partially digested food. We know that. And included in that is tryptophan. And anaerobic bacteria specifically, especially when they're in high amounts, is going to produce, as I said earlier, indole. And that's already produced in the intestine. Well, it goes from the intestine through the portal circulation to the liver. And in the liver, it gets hydroxylated and it forms indoxal. Then it's conjugated with sulfuric acid and it forms indoxal sulfate. That then gets conjugated with potassium, which leads to Indican, which is another way of saying indoxal potassium sulfate. Okay, so we got Indican. So what? Well, that goes to the kidney and that is produced, and therefore we can pick it up in the urine. And what is Indican telling us? Well, Indican has been known for many, many years. We're not rediscovering the wheel, although we're offering it in dried urine, which is really a wonderful way of doing it. Very, very easy for the client to utilize. So there are many conditions that will create elevated urinary Indican. And the most important one is dysbiosis. So if you really want to get a quick, dirty look at what's going on with dysbiotic behavior, elevated urinary Indican is going to tell you that. And how does it form? Well, if you have excess protein intake, especially the lectins, or if there's poor protein digestion. For example, in the stomach, you have low HCl, hypochlorhydria, or low digestive enzyme production, like the proteases or peptidases. Whatever that is, you're going to get elevated urinary Indican. Protein malabsorption, same issue. You're going to get increased intestinal permeability. That's going to cause it because that means there are a lot of parasitic and fungal infections, various kinds of toxins, and a plethora of whole number of other issues that can all cause elevated urinary Indican. And so it is a very quick way of being able to tell you what are the various issues that are causing it, the byproducts of intestinal protein putrefaction, which is another way of saying it is incomplete protein digestion, maldigestion, or malabsorption. The second thing that we test for in this profile is liver detoxification. And remember, this we could spend days on this, but I think all of you in practice know that liver dysfunction is a key way of being able to determine how the body functions. I don't need to tell you all these different things that can cause liver dysfunction, all the daily life overloads, as we call it. All of this can cause dysfunction. And when you're talking about detoxification, the word toxin is in there. But what is it? Well, these are various substances that disrupt the body's proper functioning. It can be overload. It can be an undernourished body that can't handle even regular stuff, which isn't overloaded. Or it can be compromised digestion. That's where digestion comes together with liver detox. And what that ends up producing is just a less effective detoxification process. So we know that detoxification, therefore, is nutrient dependent. It is critically dependent on nutrients. And so why should we detoxify? Because there are many chemicals that are associated with a whole number of chronic diseases that we all know and love well. Everything from things we don't have a complete handle on, like fibromyalgia, chronic fatigue syndrome, diabetes, which we now know to be an autoimmune disease, a whole number of other things that are along this list, which I've given you here. But at the end of the day, this busy slide, which I'm going to discuss in the next few minutes, is really looking at the pathways of classic liver function. And for those of you who've studied liver function, you know that it is separated into 3 phases. And we're going to look at these very, very quickly. But at the end of the day, what you need to remember is that the 3 phases are dependent in taking what is normally fat-soluble toxins and slowly but surely turning them into water-soluble, which is going to allow the body to get rid of it. Because unless it turns it into water-soluble, the body cannot get rid of those compounds. And so the phase 1 is really looking at the toxins, which can be, oh my God, any number of things. Exotoxins, from insecticides to microbials, you name it, drugs, alcohol, and of course the endotoxins, the various metabolites that our body is producing, bacterial and otherwise. And those are lipid soluble. And so now you have a whole number of other nutrients which are extremely important because they are going to provide us with the enzymes and the cofactors which are critical. Without them, the liver cannot do what it's supposed to do. But if you have the vitamins and folic acid and glutathione, the flavonoids, what you're going to be able to do is to go from a lipid-soluble toxin to a metabolite in its intermediate stage, which was breaking down the toxins. That's the breakdown phase. It's going to allow you, and I'm not even going to go into oxidative stress, it's going to allow you to go to phase 2, which is then neutralizing it. So, okay, you've detoxified. Now you want to neutralize by making this even more water soluble. Again, you need nutrients. You need the amino acids that are going to conjugate with whatever these products are that you want to detoxify completely, glycine and taurine, etc. And you're going to conjugate with these, meaning you bring them together in a very strong bond through any number of reactions, which I'm sure you've read about, whether it's glucuronidation, sulfation, etc. And you're going to end up with, at the end of all of that, with an excretory waste product, which is water soluble. And that's going to allow the body, the liver definitely, to go to phase 3, which means it can let go of these neutralized entities and either send them through the kidney and then into the urine, or in some cases into the gallbladder, into the intestine, and then sent out as feces, as stool. So that's what we're looking at when we look at liver toxin. How do we deal with that? How do we actually test for it? Again, we are using a classic testing modality. We're not rediscovering the wheel. We are using the most well-known way of doing it, and that's for looking at the bile acids. We look at the 12 bile acids, which are the classic bile acids you pick up in the liver and intestine, and we're picking it up in the urine. And by the way, there are dozens of bile acids, but we are looking at the 2 primary ones, cholic acid and chenodeoxycholic acid. Knowing the names is not critical, but the bottom line is that there's bile acid synthesis in the liver everything starts with cholesterol, and you eventually go through the primary bile acids, the secondary bile acids, which are produced in the intestine, and finally, all of that ends up in the urine in conjugated forms, and those are the 12 bile acids that we actually test for. An elevated total bile acid, which is what TBA is, has many causes and effects. And I just want you to be aware that if you look at that, you're going to be able to see very quickly some of the effects of things like obstructive jaundice, cholestasis, various forms of hepatitis, liver sclerosis, etc., and as well as problems of diabetes and so on. And the signs and the symptoms are very well known. If you're in that field, you know them well. Unstable blood sugar levels, very poor metabolism, the various triglyceride elevations. In terms of symptoms, the classic headaches, the irritability, people who come in depression with hormone imbalance, and of course, putrid body odor, which is a giveaway in many of these cases. And the same with low. I'm not going to go into low TBA levels. It's the same kind of idea. And if you get to know these well, it is a very valuable and very quick test to be able to give you an overview. The third part of this metabolic wellness profile, I would actually consider as probably the most important part, because it deals with what we call cell oxidative stress. And we know that there are many causes of cell and DNA damage within the cell. Everything from UV light, radiation, smoking, pollution, inflammatory problems, and of course, metabolism. The mere fact that we live causes these problems. And the major cause of this damage is what we call oxidative stress. Well, what is oxidative stress? Because it's bandied about, it's a multi-billion-dollar industry in dealing with oxidative stress. What do we really mean? Well, oxidative stress is in fact what happens every moment of our life, because with the use of oxygen by the mitochondria in the cell, we are going to produce free radicals. It is a part of what happens in the oxidative chain to produce energy. And so any species that contains one or more unpaired electrons and participates in a biochemical reaction, that means every cell, every moment of the day, is going to produce free radicals. So if you remove an electron, it's called oxidative state. If you receive an electron, it's called a reduced state. And it's that transfer of the electron which is called the redox reaction. That, in a nutshell, is what oxidative stress is all about. So no, you can't go home yet, because what does it mean? Well, oxidative stress, we'll call it OS. We know, therefore, that free radicals are produced in every cell of the body during normal metabolic processes. It's not a dirty word. That's what happens. Luckily, we have antioxidants that are constantly neutralizing these free radicals. So you and I aren't aware of this, because if you're in good health, it's because there is a balance of the oxidative stress and the antioxidants. The problem occurs when there's an imbalance between these various reactive oxygen and nitrogen species and our body, our system's ability to detoxify that. And that's when the problems begin, and you can't repair the damage, because if you've got these free radicals, it's causing damage. So oxidative stress increases, as I said, oxygen species in its various forms. Where does it come from? It comes from everything. Endogenously, just our mitochondria doing the thing they do to keep a cell alive, etc., including bacteria, by the way. And exogenously, it comes from any number of things. Antibiotic, pesticides, all kinds of chemicals that we use, you name it. The effects are multitudinal. You can have both physiologic effects, which means our antioxidants are able to neutralize it, or pathophysiological, because it can't keep up, and then you start having the damage, and it can damage everything in the cell. The lipids of the membranes, the proteins, the DNA, the RNA, you name it. And so we can look at markers that look at oxidative stress, looking at both endogenous and exogenous, and we can look at everything from DNA oxidation, protein oxidation, lipid peroxidation, you name it, all kinds of stuff. And is it important? You bet it's important, because here's just one example. And when we give a detailed lecture on this, we spend an hour just going through the various types of metabolic dysfunctions. But here's one, the intestinal barrier and the protection against oxidative stress. Because one of the things you want to do is protect the barrier so that you don't end up with free radicals leaving the intestine and getting into an area they shouldn't be in, because that's going to cause cellular protein carbonylation. That means you're breaking down the ability of the cell to properly work with the proteins. And that is going to break down the tight junctions, and you end up with intestinal permeability. So you really need to be aware that oxidative stress affects the intestine in many ways, including the loss of tight junction integrity. And remember, if you lose tight junctions, you are then getting increased intestinal permeability, and that ain't good. So we are going to look at the one thing we test for in this particular profile, which is DNA oxidation. And why do we do that? Well, I can tell you there are many biomarkers that one can choose from, a whole number of them, and they're all quite interesting. But you need to look at the one that can give you the best evidence of what's going on. So when you have diurnal and inter-individual variability, in healthy individuals, you need to look at what biomarkers are going to give you the best result. And there are 7 of them that are well known, very well known in the literature and in clinical work. And I've shown a whole bunch of them here. A good number of them look at the lipids. Some look at protein. But the one that we have chosen is the one that affects the DNA of the nucleus of the cell. And it's called 8-OHDG. And it is, in our humble opinion, including a lot of literature, to be the most suitable biomarker for oxidative stress, especially in spot urine samples when you're doing it in urine. Because DNA oxidative damage test, which is really what we're looking at here, this is 8-OHDG. The bigger name is 8-hydroxy-2-deoxyguanosine, big name. So it is a biomarker of, and this is important, cumulative cellular oxidative stress. In other words, it is not an acute marker, it's a cumulative marker. So it doesn't matter what minute of the day you did the test. When it's accumulating, it doesn't disappear after a few minutes, whereas some of these other biomarkers will disappear quite quickly. So what you need to know is that 8-OHDG and its increased levels is associated with many dysfunctions and diseases, and it is really the important one to look at. And why? What does it do? Well, 8-OHDG does its magic by actually oxidizing one of the 4 classic bases that make up DNA. So when you oxidize guanosine or guanine, you form 8-hydroxy-deoxyguanosine, and that causes all kind of genotoxic instability, which can lead to cell death, otherwise known as apoptosis, or altered cell behavior. Another way of putting that is malignant disease. And so that's all I'm going to say about that, but that's our dried urine test. I'm going to spend the last few minutes discussing the one last test that we do, and the one that we've done for many years, and that is what we're calling our mucosal barrier assessment. And it consists of a number of things, beginning with zonulin, which is the first objective biomarker for intestinal permeability, histamine and diamine oxidase, which test for inflammation of the gut, food sensitivity tests, and Candida, which we test as a sweet. And so let me go over this. First, let's just take a quick look at intestinal permeability and barrier integrity with zonulin. So when you talk about intestinal absorption, all of us know very well that the intestinal mucosa actually has quite a paradoxical role. On the one hand, it needs to be able to absorb nutrients, but at the same time that it's doing that, it needs to be able to exclude toxins and macromolecules. It doesn't want to let those in. So if you get a breach of the mucosa, in other words, when you have an open area, it can lead to a whole number of things, including malabsorption, which we discussed a few moments ago, and an increased exposure of the body to toxins and various other kinds of antigens. So that brings up the issue then of intestinal permeability. So what is that? Well, there are two ways that you can get movement across the gut wall. One, which is the lower thing here, is transcellular transport, right? The classic way in which you break up proteins into amino acids, and you break up carbs into their micromolecule stage, and you bring them right through the cell. But there is another way, and that is to have some of these things come in between the cells. And so you need to have a system that knows what's it going to allow to go in between the cells and what gets in there by mistake. And so zonulin is a peptide together with another small family of peptides. And that group controls, very important, controls the opening of this para or intercellular tight junction pathway. It's a defensive mechanism which actually is developed to flush out microorganisms. If you've got bacteria in the gut that you want to get rid of, you need to be able to open up the door and shoot them out into the intestinal lumen so they can be sent out in the stool. But things that go out can also come in. So you need a biomarker that can show intestinal permeability. And zonulin, to date, is the only physiological modulator of intercellular tight junctions. And I must tell, by the way, that's the reason why we got into the intestinal biomarker business. And I'm not going to go into this in great detail. Many diseases associated with zonulin, autoimmune diseases like inflammatory bowel disease, Crohn's, ulcerative colitis, celiac disease, diabetes, multiple sclerosis. I even put a question mark at autism. It's now seems quite likely that it has a very significant role to play there as well. A whole number of very important autoimmune diseases. I'm just going to mention one in particular, celiac disease, of which we have a very good idea of how that functions. We do know that you have a genetic predisposition for people with celiacs. 95% of them have very high receptors, the HLA-DQ2 or 8 receptors. I'm not going to go into that, except that you need that in order to have a predisposition. Second thing you need with all of these diseases and dysfunctions, you need an environmental trigger. What is it in the case of celiac? As you know, it's gluten. More specifically, it's the alpha-gliadin portion of the gluten. You need some form of dysbiotic behavior that is going to stimulate that, which then causes an immune response, a dysfunctional immune response, which can lead to celiac disease. And last but not least, if you have people with celiac, they produce 20, 30, or 40 times the amount of zonulin as a non-celiac does. That increases intestinal permeability, and that is one of the first things that shoots off the response of chronic inflammatory response in the gut of celiacs, and that's what gets the ball rolling. And most of what happens there is a response to gliadin in the diet. And people with celiac, by the way, are really responding to gliadin in the way that most of us respond to a series of bacteria that we want to get rid of, or any kind of overgrowth of bacteria, fungi, parasites. In other words, it sees gliadin in that same way. And so it over-responds, and that's what ends up with the problem. What about intestinal inflammation? Well, we test for that by looking at histamine and DAO, diamine oxidase. And we know about histamine. Histamine we've known for decades. It is a biogenic amine. It is produced all over the body in many different ways, and there are 4 different types of histamine receptors. We're gonna really look here more at the ones in the gut, which are the H2 receptors. And histamine is involved in any number of things, from local immune response, it's a neurotransmitter, and also it regulates physiological function in the gut. And it is controlled by 2 specific enzymes. The one that we're going to look at is diamine oxidase, which is in the gut and produced in the gut, and its reason for being is to oxidatively deaminase histamine. In other words, it breaks it down. And so DAO is a protein in the cell membranes, little vesicles in the villi of the barrier cells of the intestine. And DAO activity is actually unique among intestinal mucosal enzymes, and its circulating levels is an excellent marker of mucosal maturation, of its integrity. And if you look at serum DAO, diamine oxidase, and its activity, it correlates very well with intestinal permeability of the small gut. So what do you need to know? If you've got intestinal barrier damage, due to whatever reason, mechanical, microbial, enzymatic, or all 3 for that matter, it could be due to genetics, could be due to dysbiosis, could be due to infections. It definitely could be due to loss of Sig-A because you're losing mucus and the various types of antimicrobial peptides, and an increase in histamine, which is going to cause an inflammatory response. If you've got that, all of that causes a loss of the barrier and its integrity. And so if those mucosal cells of the barrier are starting to get inflamed, it's going to cause a real vicious cycle, which leads to intestinal permeability. And when you start getting into that, DAO is an excellent biomarker, not just for early mucosal injury, where it actually increases because just a general inflammatory response, but even more important, if it goes on for a long time, it's going to increase apoptosis, meaning the cell is giving up, it's starting to die off. When that happens, because of the dying off of the cell, it can't produce DAO. And the DAO is going to go down, even in the face of high histamine. And that makes it a very valuable thing to look at. In the last few moments, I'd just like to remind you that we do Candida. Remember about Candida albicans. It's a yeast, as we all know. It's found in the body. It's found in the intestine, of course. And it colonizes the mucous membranes. If it passes into the bloodstream, there's going to be a humoral system response to that, and there are going to be antibodies that are going to shoot off because of that. And you can test for that in the blood or in the stool. When you test for it in the blood, what you're really testing for is the antibodies to Candida. If you test for it in the stool, you're really looking mostly at a Candida antigen. It's a very different thing that you're looking for. And what we look for is what we call the Candida suite. We want to know not just the classic IgG response, which tells you that there was a various types of Candida overgrowth, but it could be a past problem or a prolonged infection. We also want to know, is there the beginning of an infection, and is there such a strong infection that it's also starting to give you an IgA response? Because if that's the case, IgA normally does not show itself in the blood. It normally will stay strictly in the mucous membranes of the intestine. If it starts showing up in blood, that means you've got yourself a problem. Last but not least, in our intestinal IQ series, we also have a very sensitive food sensitivity total IgG, 88 foods, which we do offer to those who would like to do it. We offer it not so much to look at any individual food, but our reason for doing it is really to look at enzymatic dysfunction. We want to know, where is the enzymatic imbalance? Is it coming from the stomach? Is it coming derived from pancreatic enzymes, or enzymes coming from the bile system? And I'm perfectly happy to discuss the reasons why we do it and some of the issues that we have with food sensitivity testing. So, in summary, we do non-diagnostic complementary screening tests, which can be done by any healthcare professional, and we consider it as an extremely important way of looking at primary screening. Metabolic wellness profile, to look at metabolic balance. It's done in dried urine. It looks at digestion, liver detoxification, and cell oxidative stress. Its usefulness rating is 5-star. I'm only showing you the 5-star. We can go through 4-star and 3-star. There are dozens of other tests that we can do. I'm only looking at the most important ones. We also look at barrier assessment. That is in dried blood spot, and that is zonulin. Also 5-star. Continuing also in dried blood spot, the histamine and diamine oxidase that I mentioned a few moments ago, looking at how histamine is broken down, are there permeability changes, as well as looking at food sensitivity, total IgG, and the Candida albicans suite, as I mentioned. All of these 5-star rating. And I also mentioned to you the stress hormone response, the salivary hormone profile that is in saliva, and it tests for the 3 sex hormones, estradiol, progesterone, testosterone, the adrenal hormones, DHEAS, and of course cortisol, the 4 cortisols, and looking as well at melatonin and secretory IgA, known as SIG-A. And for those of you who will want to know more about it, we have a 40 or 50 page manual which goes into detail of all of these things so that you can actually look at it to your heart's content, and it'll explain how many of your colleagues actually look at all of this.